Welcome. I'm John Davy Bowker, and it's a great pleasure to kick off this launch presentation on the Riverfly Extended Scheme. Firstly, for those of you who've never heard of Riverfly monitoring, I'll say a few words to explain what this is. Riverfly monitoring refers to the collection of samples of freshwater invertebrates from streams and rivers. Major groups of invertebrates, such as stoneflies, mayflies, caddisflies and shrimps, are identified at the riverbank, and a simple score can be calculated. This enables citizen scientists to quickly assess the ecological condition of a watercourse. Here in the UK, riverfly monitoring is typically carried out at monthly intervals, and the scores obtained can be compared against a target or trigger value to determine if a river is healthy. The current riverfly monitoring system, the Anglers Riverfly Monitoring Initiative, or ARMI for short, comprises 8 commonly found freshwater invertebrate groups. In this talk, we will present the new Riverfly Extended Scheme. This is based on 33 groups of freshwater invertebrates. The new Extended Scheme achieves 2 major goals. Firstly, it generates more detailed information. This enables more subtle forms of environmental degradation to be identified. Secondly, it enables existing and experienced riverfly monitors to further develop their skills. 7 people have worked on the new scheme over the last few years. They're shown on our opening slide. 4 of us will present the scheme, and I'm now going to hand over to Richard Chadd from the Environment Agency, and Richard is going to start us off by telling us why the new and extended scheme was needed.
Hello and welcome to the launch of the Riverfly Extended Scheme. My name's Richard Chadd and I work as an ecologist for the Environment Agency based in Lincolnshire. So why was it necessary to come up with an extended scheme? The old scheme was very effective and had been used fairly extensively all over the country in bringing river quality up. However, there were certain problems with the old scheme. In some cases where the impact on the river was rather subtle, it was true to say that little could really be shown using the 8 taxon scheme. And of course this was somewhat demotivating for the individuals. They also could see all sorts of things that they weren't being asked to identify and were motivated to find out what they were. So the scheme was brought up in part to give the volunteers more to do and stretch them a little, but also to provide more information for regulatory bodies such as mine to actually do something about river quality. So bringing in stress factors that the 8 taxon scheme didn't necessarily bring up, such as reducing flows or siltation. So what was the rationale behind the taxa that we chose? You can see there that there are 3 fundamental groups that we came up with, in part drawing on classifications in established metrics, published papers that look at subtle effects such as siltation and lowering flows. So in a broad sense, we came up with highly or moderately sensitive animals to reduced flows or deposition of fine sediment, or highly or moderately insensitive animals, those that actually thrive under conditions where there is lowering flow and high siltation. We also felt that it was important to bring in taxa of conservation importance, so neutral species that didn't necessarily show anything of any indicator value, but that were ones that we needed to keep tabs on, such as invasive species and protected species. Having then come up with the general concept, we then tried to develop an index of some simplicity around these additional groups that we were bringing in. It very much leans on the old 8 taxon scheme ARMI score, but is a little more accentuated in the way that the list is itself. So for the siltation and flow score group 1, so the taxa that we would regard as being positive, The more there are, the better the score is. So for the logarithmic scale of A, B, C and D, they score 2, 3, 4 or 5, depending on how numerous they are. The water quality score that goes alongside it is always positive, but it may be accentuated for particularly sensitive species that particularly do not thrive in water quality that is rather poor. For the group 2, the negative scorers, you can see there that for the same abundance ratings, A, B, C and D, they score positively in low numbers, which is as it should be. In and of themselves, they don't indicate something is awry, so that if they're in low numbers, this is not a problem. But as they become dominant, that's when we're starting to show problems. In the water quality score, they tend to be generally positive in the range 1 to 2, somewhat like the old 8 taxon scheme. But some key indicator taxa don't score in moderate abundance, or they reduce the score in high abundance. This is things like oligochaete worms, which at high abundance show there to be a water quality problem. And then there's the flow score 3 group. This includes crayfish, native and non-native, and showing the difference between the two. The purpose is to add in detail on invasive species or protected species.
Hello, my name's Will Bartle, and I'm the monitoring officer for a project called the Lincolnshire Chalk Streams Project. The project has had volunteers carrying out riverfly surveying since 2013, but a new extended scheme was created in 2015 by Richard Chad and Chris Extance from partners at the Lincolnshire and Northamptonshire Environment Agency. It was suggested that a pilot scheme trial be run using existing trained riverfly volunteers to test the new system, as they already had the relevant equipment and experience of kick sampling and identification. On the 15th of May 2015, Richard and Chris delivered the first training day to 11 volunteers. The new scheme extended the number of invertebrates from 8 to 26 and introduced a new scoring system. So the training included help on identifying the new invertebrates, scoring them, and time to practice with a live sample with experts on hand to help out. To help in the field, volunteers were also given extra equipment, an ID sheet from the Environment Agency listing the 26 invertebrates and detailing some of the key identifying features, the FBA's Guide to British Freshwater Macroinvertebrates for Biotic Assessment, and a jeweler's loop, giving 10 times and 20 times magnification to aid identification at the riverbank. Initial surveying went well, but highlighted a couple of issues. The first issue was the best way to record the results with the new scoring system. The second was the identification of some of the new invertebrates. New additions such as hoglites were fine, but some of the flatworms and leeches proved more challenging to some of the volunteers. To solve the issue of how best to collate the new results, one of our brilliant volunteers, Ian Fazackley, designed a database to calculate the new score and store the data. But unfortunately some volunteers had problems with compatibility on different computer systems. Eventually, it was decided that Google Spreadsheets was the best system to use because it allowed data to be shared easily and was compatible across the majority of computer operating systems. It also gave us the option to add links to useful ID guides for the individual taxa. Feedback from the volunteers asked for more photos and detail about habitat and what the individual invertebrates indicated, so again key volunteers stepped in to help. Volunteer John Bolton kindly submitted a library of photos to use. Jade Oliver started designing, researching and putting photos into individual ID guides, and volunteer Rachel Graham collated information and took a lot of photos to finalise detailed ID guides for all of the 26 invertebrates. Jade and Rachel also started making videos of each of the taxa as an aid to IDing. These were uploaded to Google Drive and linked to the ID sheets. There follows a couple of examples. The videos were uploaded to Lincolnshire Chalkstream Project's YouTube channel, so they could be accessed easily by anyone and linked from the ID sheets for the volunteers. The next stage was to work with groups from other areas of the country who were interested in piloting similar schemes, with an aim in producing an extended scheme that could work nationally. John Davy Bowker and Angus Menzies designed and trialled a similar scheme in Dorset, and in the following slides they will explain how they ran their pilot project, how the new extended scheme developed, and how it will be delivered.
Thank you, Will. So now let's look at the development work that's taken place in Dorset. Back in 2015, we held a workshop to evaluate the Lincolnshire system and get feedback from volunteers here. This was really informative, and we got to see things through their eyes. Some key points emerged from that workshop. Firstly, it was clear that volunteers were struggling to distinguish some of the groups. Secondly, when asked about a hard copy chart versus an app, there was a strong preference for a physical chart. Thirdly, the volunteers were somewhat bewildered by the invertebrate Latin names and asked for common names to be used wherever possible. Following the feedback, we stepped back to evaluate what some of the broad considerations of a successful extended Riverfly scheme should be. So, for example, we felt it was important that the scheme should be applicable across the whole of the United Kingdom, including upland rivers in Wales and Scotland. It should use the same sampling method as the Army scheme, and importantly, it should add value both in terms of better data and in terms of providing a training pathway for volunteers to expand their skills. We thought the extended scheme should contain within it the 8 Army groups, so that users could derive 8 group results and scores, and also so that users could revert back to the 8 groups if they found the extended scheme too difficult. We also felt that the new chart should use photographs of live animals wherever possible, just as they would be seen in the field, and that those photographs should encompass the variety of invertebrates likely to be encountered within each group. So, how did we derive the new system? Well, we went back to first principles. We used a large existing database of freshwater invertebrates across the UK, the Riverfly database. From this, we extracted 132 groups or families that were found. We then tried combining these into extended Riverfly groups that we felt the volunteers could easily distinguish at the riverbank. So, here for example, we took the 8 families of freshwater snails and felt confident that users could readily distinguish a group as snails. Similarly, we felt that flatworms could be distinguished from leeches, but anything further than that was not practical. We then tested a pilot 28 group scheme across several locations in England and Wales, covering different types of streams so we could get further feedback. Before going on to present the resultant scheme, I'll say a few words about taxonomic resolution. This will help place the extended Riverfly scheme in context with the Army 8 group system, family level identification and species level identification. So, firstly here we have the established Army 8 group scheme. There's then quite a big jump to family level identification, where anything from 82 to over 130 families can be distinguished, depending on the particular taxonomic level chosen. This step up in effort is usually associated with a change from field to lab-based identification, and it's beyond the scope of a field-based volunteer method. We then have mixed taxon level identification, as used by the Environment Agency, SEPA, NRW and NIEA. Here, the main groups of invertebrates are identified to species level, but the more difficult ones, such as worms, fly larvae and bivalves, are just identified to family or genus. And finally, we have full species identification, where everything is identified as far as possible, typically as far as identification keys will permit. We sought to place the new extended scheme between the Army 8 groups and family level identification, and we were aiming for around 20 to 30 readily distinguishable groups. So, following the testing of the Dorset system with 28 groups, we then joined forces with the Lincolnshire team and integrated the 2 pieces of work by combining some groups and splitting others. This led to a combined scheme with 33 groups. We settled on this new system in November 2018, and then work commenced to obtain the missing photographs and write the new field identification chart. By November 2019, this was complete. So here's the new chart. We're all very pleased with it. It's a double-sided fold-out chart comprising the 33 groups, and they are presented from the simplest, the flatworms, to the most complex, the flies. It's populated nearly entirely with colour photographs, and these are from live specimens photographed in the field. So let's take a tour of those groups. So firstly we have the soft-bodied organisms. So we have the flatworms, the freshwater snails, the limpets, bivalves, the worms and the leeches. Then we have the crustaceans. So we have crayfish, water hoglouse, freshwater shrimps and invasive non-native shrimps. And for two of these groups, 7 and 10, that's the crayfish and invasive non-native shrimps, we're asking the users, if possible, to record the species if they know what species is present, because that's useful additional information. We then have the mayflies, and being a riverfly chart, it's quite rich in mayflies, so we have 6 groups included: Anglus curse, olives, prong-gilled, flat-bodied, green drake and blue-winged olive. We then have groups 17 to 22, so this is quite a mixed selection. We have the stoneflies, the dragonflies and damselflies, water boatmen, as distinct from the following group, which is all the other water bugs. And then group 21, water beetles, and that comprises adults and larvae, and group 22, the older flies. Then have groups 23 to 29, and these are all the caddisflies. And finally groups 30 to 33, and this is the true flies. Moving on to the chart itself, here's a close-up of one of the panels for, in this case, group 23, caddisfly, the green sedge. We've obviously got a photograph, and in this case a couple of zooms on important identification features. We've then got a section called Distinguishing Features with bullet points giving indications of what to look out for to distinguish this animal. We have an indication of maximum body size, larval habitat and diet, what this group feeds on. And then there's a space for the user to write their own notes for their own observations. Maybe how the animal swims, how it moves, what they've noted about it. And then in the bottom right, we have information on tolerance to stressors. So here we've summarised information on how we know this group behaves in relation to environmental stress. So in this case, the green sedge is not tolerant to nutrient enrichment. Neither does it like slow flow or sedimentation. However, it's less impacted by acidification, so you will find it at mildly to moderately acidified sites. And we feel that nutrient tolerance section summarises a lot of information about each group in a very compact and accessible way. And finally, for the expert users, in the very small print right down at the bottom, we give the specific family names within each group. In this case, it's just the family Rhycophilidae, but in a big group like the water beetles, it might be more than 10 families. So moving on, let's look at the Riverfly field recording form. This is a double-sided A4 form where you can record the site details and information for up to 6 surveys in a given year. This is where you can add those estimates of numerical abundance of each group on each survey occasion. You can see on here how to combine the 33 groups to derive an 8-group army score and therefore determine if you've had a trigger breach or not. And you can also note down what that trigger number is for your site. So that's page 1, and then on the second page we have some information on what we know to date about a database. We also have a reminder on how to calculate that 8-group army score and details of the new Riverfly Extended Scheme indices, which I'll cover in a moment. So here's a close-up of page 1. You can see the 33 groups listed down the side, columns for 6 surveys, April through to September, and all the white boxes to record those estimated numerical abundances. So this is page 2, and there's information on submitting data, and so I'll cover that on the slide following. There's that 8-group Army score information, reminder on how to calculate the 8-group Army score. And then on the right hand side we've got the new extended Riverfly scores. So these are scores using now all 33 extended scheme groups. So let's have a little look at those. There's 2 scores. We've got the water quality score and the silt and flow score. And they're a little bit more complex than the 8-group score. The 8-group score, back in the orange box, you basically just got more points as you moved up through log abundance categories. So you got a 1, a 2, a 3, or a 4 as you went through kind of like 1, 10, 100, 1,000 individuals. Within the extended Riverfly scores on the right, in the blue panels, you can see that these numbers don't follow that same simple pattern. There's quite a bit more going on. So let's look at water quality score. If you take, say, the mayflies, so they begin at groups 11 running down to 16, you'll see that the scores for some of the groups actually start quite high and then level off. So you're immediately into 3s and 4s right from the start. In stoneflies, you get a 4 straight away just for any of them. So these are basically groups that even having them in low abundance is a positive indicator of good water quality. Okay, similar patterns going on in the caddisflies. And the flip side of that, what about an animal that is very tolerant of degraded water quality? Well, let's take group 5, the aquatic worms. If you have them at low abundance, you get 1 point. Higher abundances, you get 0, and once you get them super abundant, above 1,000, you drop down to -3. So it takes points off the overall score. The same with group 32, the non-biting midges. You get -4s once you get above 100 of those. They're indicators of a distorted community. So let's try and imagine what a site degraded with poor water quality. You lose all the diversity and you're left with those pollution tolerant things. In extreme case, just worms and non-biting midges, and you've got a terrible score. So the point of that score is it discriminates high water quality from low water quality using all those different behaviours of the different groups. Exactly the same principles apply for the silt and flow score. So let's have a look at the caddisflies, groups 23 to 29. They're quite interesting. So the pattern here is the scores either elevate, beginning at 2, going up through to 5. So these are groups where having more of them is a positive indicator, telling you that you haven't got a problem with silt and flow. Or in the example of, say, the Hood casemaker, group 26, the score starts at 2, but it goes down and goes negative, down to -2. So this is the Hood casemaker is a caddisfly that is tolerant of silt and low flow. So it actually quite likes that kind of habitat. So if all the animals you find in the water course have got those kind of negative type behaviour, those numbers, there's an indication there's a silt and flow issue if it's a flowing water course, or it should be. So yeah, quite a bit going on in those scores, a lot of information and a lot of potential for discriminating both general water quality issues and problems with silt and flow. Okay, following the route of data from the recording form, the database. We don't have a database as yet, but we have 2 main options. Those are the FBA Riverfly database, an expansion of that, or the Cartographer Citizen Science database. We don't know which of these two paths or a blend of the two we will go down at the moment, but Dave Gunnell at Cartographer has recently developed a pilot system for us, and that's going to be evaluated in spring 2021. So hopefully we will have a nationally applicable extended Riverfly database available to users in 2021, but we don't know exactly what shape and form that will take. That's all from me. I'm now going to hand over to Angus, who's going to round off the presentation for us.
The Extended Riverfly Scheme has been developed as an extension of the 8 Group ARMI scheme. And to ensure the credibility of both, approved training is fundamental. High quality training will do much to ensure that good quality data is submitted and is recognised as such. Accordingly, the charts and recording forms will be available to those who have attended training workshops. The chart may be purchased at a training event for £10, whilst the recording forms are provided free of charge. Since 2015, we have held a series of trial extended workshops for monitors, led by John and assisted by Mitch Perkins, until recently a freshwater ecologist at the Environment Agency. In these workshops, we have sought the opinions of our local monitors and modified the delivery of the training. On repeated occasions, we have found that our monitors are keen to identify and record a larger number of invertebrates, many of which would not previously be familiar to them. As with the 8 Group ARMI training, attendance at an extended Riverfly workshop is recognised by the Riverfly Partnership with the award of a certificate. At all times, we have been clear that the extended scheme is not a substitute for the 8 Group ARMI scheme. Rather, it is complementary to it, providing additional useful information. And from our pilot workshops, we did find that it would be difficult to use the extended Riverfly's chart and to submit data without previous experience of the 8 Group ARMI scheme. Riverfly monitors survey their sites for a large variety of reasons. Many dedicated monitors survey out of concern for a local stream or river and are very happy with performing a monthly survey using the 8 Group scheme. However, others interested in gathering additional data for long-term trends have signed up to the extended scheme and requested additional training. Recognizing this difference in individual focus, we are clear that there is no expectation that a monitor moves from identification of 8 groups to 33 groups. It is a matter of personal choice. Of interest in Dorset is that we are using the 33 groups to monitor trends in invertebrates following the intended introduction of beavers at an enclosed site in the county. Although the chart can only be purchased at a training workshop, we hope that the trained monitor may subsequently use the chart at other events to promote awareness of river life amongst people of all ages. This has been done very successfully in a wide variety of settings, including primary and secondary schools, further education facilities, and Wildlife Trust open days. Finally, we all should like to take this opportunity to thank the large number of individuals and organisations who have contributed in very different ways to the success of the extended Riverfly scheme. The scheme really shows what can be done by river enthusiasts, professional and amateur alike. It is citizen science at its best.